Hi boys, I have another video here dealing with sine and cosine. The only difference with this video is we're just going to be focusing on finding missing leg lengths. So you should have a calculator or a phone nearby because you will need it in order to figure out the values of each of the legs, or one depending on the example. So in the first example, I want you to find each of the leg lengths. So you're going to have to use cosine and sine. To recap from the last video, we learned that the ratio for sine was the opposite side over the hypotenuse. And for cosine, we learned that it was the adjacent side over the hypotenuse. So it doesn't matter which one you start with, but you just have to determine which variable refers to which trigonometric ratio. So if I wanted to solve for x first, I notice that x is opposite the angle 26 degrees that is given. So I want to use sine because of its opposite from the angle. So the work would look like this. We'd have the sine of 26 degrees is equal to the opposite side of x over the hypotenuse, which is 14. Then we would cross multiply like we learned in the tangent video, and I would say 14 times 26, which is written out here, is equal to x times 1, which is just x. So in our calculator, we just have to compute this math to find out that our answer is, in fact, 6.1. So in your calculator, when the answer is not given, you would be typing in 14 times the sine of 26, and would you look at that? We have about 6.1 units for our length. Now to go back to the cosine length, we're just going to reverse these operations. So to find y is adjacent to 26 degrees. So instead of sine of 26 degrees, it's cosine. And then instead of x in the numerator, it's going to be y, adjacent side over hypotenuse. So that denominator doesn't change. Now to solve for y, we're going to be multiplying 14 times the cosine of 26. So notice some of the work, you're just deleting things out and inserting in a different trigonometric ratio and variable. Now this isn't going to equal 6.1, so when we go back to our calculator, we're going to say 14 times the cosine of 26, and our leg length for that is about 12.6, which is what that squiggle equal sign is. Now for the rest of the examples, you're only finding one leg at a time. I just want to focus on setting up what trigonometric ratio we're using. So for 41 degrees, I want to get x. Now I notice x is the hypotenuse, so I can't determine specifically if it's cosine or sine. So I have to look at the other side that's given. So I see 41 degrees, and opposite of that is 12. As soon as you think opposite, you want sine. So we'd be typing in the sine of 41 is going to be equal to, let's insert an equation here, is going to be equal to the opposite side of 12, over the hypotenuse, which is x, and we're going to solve from there. However, when we cross multiply this time, we have x times the sine of 41. So we're going to have x times the sine of 41 is equal to 12. And then to get x by itself, we have to divide both sides by the sine of 41. So x would be equal to 12 divided by the sine of 41. And we take out our calculators, and we would say 12 divided by the sine of 41 is equal to about 18.3 for that x leg length. 18.3. Now in the next examples, I'm just going to copy and paste the work and delete stuff out. We're going to be dealing with cosine instead, because, actually, let's just delete that off. I see that 19 is adjacent to the angle that's given. So that as soon as you think adjacent, you think cosine. So I'd be entering in the cosine of 47 is equal to 19 is in the numerator because it's adjacent to the angle over the hypotenuse x. And just like number 2, when we cross multiply, it's going to be x times the cosine of 47 is going to be equal to 19. And then to get x by itself, we divide by the cosine of 47. So x is going to be equal to 19 divided by the cosine of 47. And if we enter that into the calculator, 19 divided by cosine 47. We have about 27.9 for that leg length. Now the last two, very similar, but I'll walk you through what those would look like, and you can try the math out on your own. So in number 4, we are dealing with 43 degrees, and I'm going to solve for x. And what I notice is 20 is the hypotenuse, not the adjacent side. And I know it's the hypotenuse because it's across from the right angle, so just be careful when the triangle is twisted around. And I notice that x is opposite 43 degrees, so I want to be using sine. So in the number 4, we'd be setting up the sine of 43 is equal to x is in the numerator because it's opposite over the hypotenuse 20. And in 5, I see that x, once again, is across from the right angle, so that is the hypotenuse. And I notice that for 75 degrees, that's this angle right here. 20 is adjacent to 75 degrees, so I want to use cosine. So I would have the cosine of 75 is going to be equal to, you have to back that one up a little bit. It's going to be equal to 20, which is adjacent, over x, which is the hypotenuse. So 20 over x, and you would just cross multiply and solve for each of those examples. I hope this video was helpful, and good luck with the rest of your homework.